Okay, welcome. So in these last couple of videos for this module, I want to just end talking about parallel computing and how that applies to apply functions. So we can speed up computations when we do them in parallel processing. So that means doing multiple tasks in parallel simultaneously instead of one at a time. So to illustrate this, you can imagine when we were constructing bootstrap distributions, we pick a bootstrap sample, we calculate a mean, we store it. Then we go to another bootstrap sample, we calculate the mean, and we store it. But what if instead of picking one sample at a time, I ran this in parallel, like with 10 processes? So each time we're going through this, I'm picking 10 bootstrap resamples simultaneously, calculating their mean, and then going back and then picking 10 bootstrap resamples simultaneously, calculating their mean, and so on. So parallel processing we can use with these apply functions, in particular L apply, S apply, V apply, to perform complex analysis of a sequence of simulated data sets, just like I was describing with bootstrapping. And so the analysis can be performed on each simulated data set separately, which means these operations can be parallelized. So what that means is we can think about each bootstrap resample as a separate data set. And why do we need to pick them one at a time? Can't we just pick like 20 bootstrap samples, calculate their means, and then pick another 20 and so on? So we'll provide some examples, but we'll do like a much more basic function. So I'm going to create a function which is called sleep iterator. So the sleep iterator just puts your computer to sleep for 1 second. So I am going to use the lapply, and I'm going to input the data, which is a vector of integers from 1 to 6. And then I'm going to apply the sleep iterator function to this vector 1 through 6. So this is kind of like our iterator. And this is the function that's going to be run each time. And now I'm going to use the system time function to see how long does it take for this command to be run. And so what it's going to do is it's going to go to sleep for 1 second, and it's going to do that 6 times. So this should take about 6 seconds to run. And we'll see. So that is running up there. And you can see that this did indeed take a little bit longer than 6 seconds to run. So again, this lapply function is just saying, you apply the sleep iterator function 1, 2, 3, 4, 5, 6 times, and that took 6 seconds. So we'll take a look at some different packages that we can do to create parallelized environments to run these commands. The first is going to be using the parallel package, and the parallel package is already installed in Colab, so we don't need to install the package, but you will need to load it with the library command if you haven't done that already. And they provide parallel equivalents of the apply function, the lapply function, and the sapply function. And the function names to run these apply functions in parallel are par apply, par lapply, par sapply, where we're capitalizing the wildcard that comes before the apply function. So if you've already loaded the parallel package way back in the first code cell, you don't need to run this again. If you haven't, then you will need to load this package in order to use the par functions that are stored in it. And you can run !cluster apply to see additional details about these functions. We're just going to do some basics just so you get a sense of what's available and how that might speed up time. But the available options for parallel processing really depend on your operating system. we're running this in Colab, so we're using the cloud. So one nice thing about using Colab is that we have some equity in our computing. We all have the same kind of cloud computing power in Colab. If you were running some of these commands on locally on your computer, then it would be more apparent in terms of which some students might have really fast computers and others might have computers that run a little bit slower. But we can detect how many cores we have available for our computing. So if I'm running in like a very basic account in Colab, which has 2 cores. And a core is just a processing unit within the CPU that can independently execute code. So Colab is equipped with 2 cores, at least how I am running Colab in my account. I've got 2 cores, and I think that should be the default for everybody else. So I'm going to use the make cluster function in the parallel package to set up parallel processing that runs 2 processes in parallel. That's the most that I can do in my Colab. So I'm going to say make cluster, get options, and then in quotes, cl.cores, and then I'm going to indicate that I want 2 cores. So that's what this command does, and it stores that information to an object that I call cl. So now I'm going to, instead of running lapply, which is what we did up here, I'm going to run the same command, but I'm going to run parallelized. And this takes an initial argument that lapply didn't, which was how many cores are you going to run? So I stored that information into this object called cl. So I first indicate that I want to run 2 parallel processes. I'm going to run the same sleep iterator the same number of times. But now it's going to do it in parallel 2 times. So if it took 6 seconds before, you can see this is now taking 3 seconds because it went to sleep 3 times on each of 2 independent cores, which means it went to sleep 6 times. It was just doing it in parallel. So we'll take a look at some other packages that are available to run apply functions in parallel in the next video.